So when we have a trig equation where the ratio is positive, it's pretty straightforward. So let's have a look at one where it's negative, and let's look at a different, let's stick with sine for now. So let's take the sine, let's try and find sine theta is equal to negative root 3 on 2. So again, we're given our two pieces of information with this ratio, the sine and the magnitude. Now, in this particular case, we're given a negative ratio. So if we look at our quadrants, all stations to central, it turns out actually we're in the third and fourth quadrant because we have sine theta, but we end up with a negative ratio. So we must be in the third and fourth quadrant. That's important, right? A little bit different from before, but the same sort of idea. We look at the sign of our ratio, tells us where we are. Then we look at the magnitude. Now again, we can say, well, theta is going to be equal to the inverse sine of root 3 on 2. Notice that I'm ignoring that negative. This negative is ignored. I don't really care about that negative once I've worked out what quadrants I'm in. Then if we take the inverse sine of root 3 on 2, the inverse sine of root 3 on 2 is 60 degrees. So theta is equal to 60 degrees. But of course, this is our equivalent acute angle. That's why we ignore the negative. The acute angle will always give us a positive ratio. So we say, okay, cool, well, that's the equivalent acute angle is 60 degrees, but I don't want the first quadrant anymore. I want the third and fourth. Before, in the last example, we said if your angle here was theta, then the angle you need over this side will be 180 degrees minus theta. But now we're in the third and fourth quadrant. If we want the same triangle in the third quadrant, we have to go all the way around. That's going to be 180 plus theta. And then if we want the same triangle in the fourth quadrant, then we're going to have to go all the way around here. And that means we go 360 degrees, but take away theta. So that's exactly what I want. I want this and this one, which means if our equivalent acute angle is 60 degrees, then my angle, theta, is going to be equal to 180 plus 60 degrees, and it's going to be equal to 360 minus 60 degrees, because that is the equivalent angle in the third quadrant, and that's the equivalent angle in the fourth quadrant. So my two answers, and again, always two answers, we get 240 and 300 degrees.